Ladies and gentlemen, boys and girls, my name is Subrata Sarkar. I'm a mechanical engineer working in manufacturing industry more than 22 years. Today I've chosen this topic, that is a rocket engine, because of, many times what happen when we talk or discuss, and sometimes in offices, especially the engineers or technical people or scientists or those who are into the science subject. So to make understand that something is not so difficult, people used to say there is no rocket science in it. It is very simple, just do it. So it means rocket science is the toughest science actually, or rocket technology is the toughest technology. So today I'm trying to share in a very simple way to understand what is a rocket engine, or some related things like jet propulsion, how rocket works, how it looks, how it get tested, some components of the rockets, etc. in a simple way, so that after going to this presentation, you will not say that there is no rocket science in it, because it is similar to other engineering like mechanical engineering dealing with some type of engine, and it is dealing with some jet engine. So there's similarities are there. It is not so that it is not understandable. Now, when we discuss about the this rocket engine, so there is one very simple and basic term comes, that is propulsion. Because to move, propulsion means to initiate or charging the motion of a body, either for translation motion or for rotary motion, which is needed in a rocket actually. So that is propulsion. So it's an initiation or charging of the body or the structures to give the motion. That is called propulsion. Propulsions are there in ships also, but in rocket is a little different. Now, in school today we'll be talking about the space propulsion actually, under which comes the rocket engine, like controlling satellite motion, maneuvering of the spacecraft. So these are the things comes under space propulsion. And the third thing is jet propulsion, the using momentum of ejected mass, like in case of the missiles, etc. So this is comes under the jet propulsion. Now, when we classify the jet propulsion, there is one thing comes, it's called the air breathing system. So it will work where the air needs, actually air enters into the system, get compressed, get burn, combustion, then expansion, create the thrust like that. So this type of the engine is called the air breathing system. Now, if we classify the jet propulsions, so one is the rocket propulsion. Rocket propulsion is the vehicle carries its own fuel, because when rocket launches are moving, you cannot in the fuel further actually. So you have to carry the fuel. And also, importantly, like in atmosphere, Earth atmosphere, you will get oxygen to burn the fuel. But when the rocket is moving outside the Earth atmosphere, it will not get oxygen. So that is another special things is needed in rocket engine. This is called the oxidizer. And most important things, rocket engine can operate outside the Earth atmosphere. This is most important. Like in car engine, like whatever with the car, is a Mercedes, BMW or anything, if this engine taken into outside of the Earth atmosphere, it will just not function, just not get started. The technology is not totally fail actually that area. So this is a rocket engine is such that it will carry the oxidizer in the form of the liquid or in the form of the solid in a different chamber, and it will help the fuel to burn, which is needed, very much basic needed actually. Now, what are the usage of the space propulsion other than the rocket is normally called? Number one is the launch vehicles. Number two is the ballistic missiles. Number three is the Earth orbiting satellite. Number four is the upper stages, which is outside of the Earth atmosphere. And number five is the interplanetary spacecraft. And number 6 is the manned space flight. Now, we classify the space propulsion by drive in terms of what is the drive is fed into it. There are 4 types actually. like stored gas system. There is one chemical system. There is an electrical system also there. There are advanced system is also there. And advanced system comes with laser propulsion and also solar propulsion. These are the advanced things. Today I'll try to discuss, which is very simple, to petrol, diesel like things actually, which is comes under the chemical. So we'll discuss the jet space propulsion by type of chemical drives. In chemical also, there are three subcategories. One is the liquid, one is the solid form, and one is the hybrid form. Now, if we say it is a liquid propellant, how it works? In the liquid propellant system of the rocket engine, number one thing is the pump fed system, where the launch vehicles, large upper stages are needed, and the pressure fed system is there, where smaller space, stages on the space, and the spacecraft drives on these things. And monopropellant types also, there is a bipropellant types. Other two types of the chemical propulsion things are, one is the solid propellant, chemical in terms of the solid is stored into the system other than the liquid, and there is a hybrid types of system. Now, those who have gone through this engineering or the thermodynamics for the chemistry subject or heat engine subject, they know for there is a principle called there's a cycle, the petrol cycle or the diesel cycle. So it's how it works actually. So here in rocket engine there is another types of the power cycle, which is called a rocket engine power cycle, where there is you can see here there is an oxidizer kind of things, because oxidizer is needed, which is not needed in case of the automobile engine. There is a fuel pump system. Obviously oxygen and fuel needs to be pumped towards the combustion chamber, and then it really expands and passes through the nozzle, further expansions, and it will create the required thrust in the engine, rocket engine. And do you know what is the size of the rocket engine? Here you can see the size of a big rocket engine is transporting by heavy trailer. So you can see by size, there are rocket engine by size. It is maybe height is two-story building, say 20 feet, or they 4 times of a man height. So this much of big, commercially used rocket engines are there. Here is a very specific project specific rocket engine for Saturn V. Here it can create, because like in automobile engine we specified like this engine has got 300 HP engine like that, or this much of 2000 Newton meter torque by the engine. In case of when it talks about the trucks or the other vehicle engine in automobile industry, here in rocket industry, engines are specified by a single term called how much thrust it can generate. So this is the model Saturn V. It can generate 1.5 million pound thrust. So by thrust, rocket engine are specified. Now, as I said, in chemical propulsion there are two things. One is three types. One is the liquid type, one is the solid propellant type, and is the hybrid types. Now, in solid propellant type, there is a motor. It looks like the compressor for this domestic refrigerator. It looks like a cylindrical with hemispherical ends like that. This type of chamber, normally the air tanks or something in automobile industry looks like. And also the solid binders are there. But solid propellant has a one disadvantage. Once you start using, you cannot stop it or you cannot refill it. So it is a no restart capability for the solid propellant tanks. And efficiency wise also, solid propellant, when you are using its efficiency is less than the liquid propellant system. And application is mostly space vehicles are used this solid propellant, because it's a compact in size. That is the advantage of the liquid propellant. So when space is constrained, is one of the chosen factor for using this solid propellant in a rocket engine. Now, what is the basic principle of a rocket engine? Very simple actually. Number one, we all know that what is the Newton's third law of motion. For every action, there is an opposite and equal reaction. So rocket engine works on two laws or principles. Number one, Newton's third law, and number two is the law of conservation of momentum. So when the principle of the cryogenic rocket engine we discuss, they drive the thrust like all the rocket engine by accelerating an impulse carrier in the high speeds, which basically gives the thrust when it is expanded through the nozzle at the end. So this chemical energy stored in the fuel, whether it is the form of the liquid or in the form of the solid that get burned and converted into kinetic energy of the fuel, and then is further give expansion through a nozzle and creates the desired thrust. This is basically the working principle of the rocket engine. And schematically, if we say, so this is a fuel chamber like this is an oxidizer, and this is a combustion chamber, there is a nozzle. So for fuel and the oxidizer, through pumps it comes into the combustion chamber, it gets burnt and expanded through the nozzle and create the thrust. So if you see it, this is how the air actually, when air goes inside the rocket engine and come out, what is the difference of, or the, what is the immediate change in the things actually. There is the intake of the cold air, and in the space there is a compression. So when air enters, space is this much, and the gradual spaces get reduced, so air gets compressed. So after compression, there is a combustion chamber where this fuel oxidizer, get combustion burnt actually, and chemical energy converted into heat energy, and then further there is a nozzle system and it creates a thrust actually. This is one of the photographs in NASA actually, rocket engine fitted on a rocket. So it's very big actually, like maybe more than two trailer length actually. And this is the way rocket engine are tested, because it creates tremendous amount of thrust. So prototype testing of the rocket engine, like in a truck engine, etc., we can fix on a frame and start the engine. So engine will give vibration, and if we unless if we engage the transmission, so it will not move further actually. But in case of rocket engine, there is a tremendous amount of thrust generated. So it has got different testing chamber like that actually. So now finally rocket engine assembled and transported to vehicle to reach at the site for testing or applications. So I'm sure after going to this presentation, you will not say that there is no rocket science in it. Rocket science is also similar to other science, and we can understand it. Thank you very much for your time and attention.